So hi, I'm Tim Titus, CTO and founder of PathSolutions. What we're going to do is do a quick demo of TotalView to show how easy it can be used to troubleshoot network problems. First of all, the software is going to deploy on a Windows server, typically in your data center, virtual machine. This could also be deployed in the cloud, but it's something that effectively it's typically on-prem. You guys host it yourself. It's a 100 megabyte installer. Something we're kind of proud of is there's no bloatware here. This thing is not some gargantuan 4 gig download. It's 100 megabytes. Now, it can be 100 megabytes because we coded this in C and C++, so it's very efficient, very fast, yet very powerful, and also incredibly scalable. So it can monitor some incredibly large networks with a very lightweight footprint. So you install, what it's going to do is it's going to scan through the network to find and interrogate every switch, router, gateway, and firewall in your infrastructure. It's going to find all of these devices really, excuse me, within the first really hour of deployment, because you're going to give it subnets to go scan or seed routers. You're going to give it SNMP credentials, and it's going to go out and find all of these devices. When it finds a device, it's going to query it to say, what are you? Oh, you're a 20-year-old 3-com switch. Okay, we know how to talk to you. You're the latest Cisco Nexus router. Okay, we know how to talk to you. So we find out what those devices are, and then we feel the device out to say, what are you capable of? What MIBs do you support? What variables do you have? And so we pull that information, analyze it, and then come back and say, hey, guess what, guys? We found a problem on the Syrah switch. Okay, so really within the first hour of deployment, we're going to say, we put a red dot in front of the Syrah switch. You can go over, click into that switch, and see what's going on. We click in, we're going to see all the interfaces on that switch. Okay, we see there's a problem with interface number 5, and the problem relates to packet loss. Now, if I told you guys, hey, we found packet loss on a switch port, you'd probably say, so what? If that's a printer or photocopier, I couldn't care less. On the other hand, if that's a trunk port to another switch, or there's a critical voice gateway there, that could be a high priority problem. So the second thing you want to do is find out what is affected by this packet loss. To answer that question, we're going to expose all of the CDP and LLDP information so you can see what's connected upstream, if anything. We have a fully integrated port mapper that shows that interface has one MAC address. It associates with the HQ voice VLAN, VLAN number 110. We have the MAC address, the manufacturer of the device, the IP address, and the reverse DNS. Okay, this is our voicemail recording server. Now that we know what's affected, let's go see what the problem is. We click into the interface, we see the utilization graph, the packet loss graph, and then below that, a plain English prescription telling us we've just found a cabling fault. So it's that fast, excuse me, that fast and easy to find a problem on the network, find out what is affected by that problem, find out when the problem started, when the problem stopped, and what the problem is. At this point, we're in resolution mode and we're getting the problem solved. Now, this works whether you're the most junior level person on the help desk or you're the most seasoned network engineer. You're going to get the problem solved faster because we have all of the data. Now, other monitoring products couldn't even find this problem because the first thing is they're not looking at all of the interfaces. But even if they were monitoring this interface, they still wouldn't be able to find the problem. Here's why. If I go and click on View Error Counters, this is going to show us all 19 of the error counters that we're picking up and analyzing. Other monitoring products only look at inbound errors and outbound errors. Therefore, they would tell you this interface is healthy and mislead you. Because we go deeper, we're going to be able to tell you, actually, no, you've got a ton of FCS errors, you've got a few deferred transmissions, and some outbound discards. The heuristics engine analyzes the presence and absence of these error counters along with the interface type and configuration to arrive at that plain English conclusion. That way, you get problems solved faster. Now, if you want to learn about the error counters, we have an engineer's library. Just click in. We're going to give you the official IEEE definition of the error counter, a more basic lay definition, and then all of the causes as to where this problem could come from. So you're never stuck wondering, where do I go from here? Okay, so that's the depth you can go into on a single interface. Let's now do a root cause troubleshoot between two IP addresses. Let's say we have a user who was on their PC, And they said, hey, right around noon, things got really slow, and I was connecting to that server. What happened? We put in the IP addresses of those two computers and click map. What this is going to do is show every link, switch, and router used to connect those two across the network, and what happened along that path at any point in time during the day. So here's the PC. Looks like it's plugged into the Pino switch, interface number 7, and that interface looks perfectly healthy. Outbound, the traffic's going out interface 25, and we notice that around noon, looks like it had some high utilization, but there's more bandwidth available and no packet loss. So that's also a healthy interface. Okay, keep looking and say inbound and outbound on the Syrah switch looks good. Uh-oh. Outbound on the Burgundy switch, going out interface number 3, we noticed that interface right before noon was dropping 6% of the packets. I think we found our suspicious interface. We can click in, read the plain English prescription, and get the root cause of the problem resolved. So that's how you troubleshoot a problem between any two IP addresses at any point in time with all of the error counters, configuration, and performance analyzed.
Quick question, are you able to show us a demonstration in this demo of the plain English prescription, like what would have happened?
Yeah, you just click in, it's going to go down and show you the network prescription and say, oh, we've got collisions? Okay, that's stupid. But yeah, you have all that information right there.
How much setup is required on your switches and routers and things like that?
Just SNMP read-only.
Okay.
Really, part of the magic, and you talk about this, is that people will have other monitoring packages, and they'll say, yeah, I've got weird problems that are happening, but the monitoring software says it's all great. We install, and within that first day, we're going to say, no, it's not all great. Here's all of the stuff that the other monitoring software just doesn't know about. And I got to tell you, is the saddest thing is that we still find networks we deploy on and say, oh, my firewall's running 100 meg half duplex? How'd that happen? And if the other monitoring software just doesn't know about this stuff.
Why, and I have to ask John Freeman here, why is that?
The other software, they basically say, you set it up to monitor the information. Mm-hmm. You have to know what to do. You have to know what to collect. You have to know where to collect it and how to collect it.
So the onus of proactivity goes on
the customer.
Right.
We've changed that whole mantra by saying we're going to automate it and say, here's everything that's broken so you can actually fix your network on the first day.
Ron Westfall, Futurum Group. In terms of troubleshooting efficiencies, does PathSolutions share, like on average, you gain like 20% better outcome?
I'm going to say actually the troubleshooting is probably a 90% improvement. I mean, you're getting a lot of time back because you have data. So if you'll grant me the little bit of time here, a typical problem that happens and then disappears, happens and disappears. You get the manager level, director level, C-level people involved saying, hey, why can't we solve this problem? And the networking folks say, oh, well, we have to go collect information on this interface, on this router, this interface here, this. They have a whole long list of where they need to collect the information. They then spend the next couple of days configuring their monitoring software to go collect the information. Then they spend time analyzing it to find the problem. That's why typically, if the problem happens and then disappears and it's transient, it might take weeks to come to a resolution. Because we're continuously collecting all of that information, we're going to be able to pop up and say, hey, that cable's just gone bad. And that cable just went bad at 2:30 in the afternoon. What does that mean? You say, what happened to the network at 2:30 in the afternoon? Well, John was in the wiring closet. John, what were you doing in the wiring closet? Well, I was putting a new patch cord in, but I had to redress this piece of fiber. Well, guess what? You turned the fiber a little bit too tight when you redressed it, and that's causing our problems. And so it's all of that knowledge. Here's when the problem started happening because we have that information and the plain English answers. It just means problems get solved a ton faster because the data is all there.
Very good, up to 90%.
Well, most network engineers would be like, I don't want to spend weeks searching for gremlins. That's the problem. And it's frustrating because it's like, oh, I'm going to get another visit from the CIO. Oh, I'm getting another visit from the director. And now we're starting to have daily meetings. Now we're starting to have meetings every 4 hours. And it's like, the meetings don't solve the problems. Information solves the problem. And that's what we automate. Other features, we have a dynamic network map. You can set up links and sites on this. So if something goes down, within seconds, you're aware of it. This updates every 5 seconds. It's a lot more active than a lot of other products. We have automated network diagrams. So this will build a network diagram showing all of your layer 3 infrastructure, how they connect, where devices connect. You can download Divisio. We have a correlation engine. This is our Gremlins tab. The correlation engine allows you to go back in time to say what happened 15 minutes ago and say, these are all of the events that happened at that time frame, including devices that change status, interfaces that change status, devices or interfaces that had high packet loss or high utilization. That way you can correlate that information.
How far back does that go?
Sorry?
How far back does that go at that resolution?
So this will go back a day and a half.
Oh, nice.
And it's really focused on troubleshooting. It's not really on the long-term stuff. It's really just on the, hey, what happened 20 minutes ago when somebody said they had a problem. Back at the devices level, there's a ton of information behind these sub-tabs. Full inventory information, manufacturer, model number, serial number, software versions, and we also do device configuration management. So we'll back up the configs on your devices. You can go in, see what a backup looked like at any point in time. You can also do file compares to say, hey, how does this device change over the past week? What are all of the differences on this configuration over the past week that have been made? And we can see all of those changes. Other things we can do is we can do device validation checking. So if I wanted to say for all of my iOS-based devices, do they have NTP configured? Well, do a search and find out we only have 2 iOS-based devices that have NTP configured. And we can go through and review the NTP configs. Or we can do a search for does not match and say, show me all of the iOS-based devices that don't have NTP configured so that we can quickly go through and say, let's remedy that problem. Another problem we found is that if you have active passive firewalls or you have fault-tolerant devices in your network, you have to make sure that those configs are identical. If you have a different routing table, static routes, if you have different ACLs and you have a failover, it's going to be a nightmare. You're going to say, why the heck is traffic going over here? Why is traffic being blocked? And so if you had that sort of knowledge of what is the differences between our redundant devices, this allows us to very quickly say, are these configs identical, except for the device name is going to be different from device, and the IP address is going to be different from devices. Additionally, if somebody out there puts a new static route in on a router, we can send an alert out to the whole team saying, hey everyone, John just put this new static route on this router, so if the network gets goofed up, we all know what just changed. We do server monitoring, so we'll monitor all the servers in the infrastructure. We simplify this because you don't have to deploy agents, you don't have to set up server monitoring. We're going to automatically monitor every server in the domain. You're responsible for those, we'll just monitor them. That means if a new server joins the domain, it shows up in the list automatically. You click in, we'll show the CPU, the free memory, the free disk space, the network utilization, and we automatically monitor all of the services. So if any service changes status, you're going to be made aware of that and you can respond to it. We can locate any computer in the infrastructure. Now, a lot of other monitoring systems say, oh yeah, you can put in your IP address here or your MAC address and we'll find it. Because we have so much more information, it makes our search far more powerful. With ours, you can put in IP address, MAC address, DNS name, CDP, LLDP, OUI, system description. If you want to find all the Dell computers, quick click here will locate every Dell computer in your infrastructure. You want to locate all the JetDirect printers, we'll find all of the JetDirect printers. We do cloud service monitoring. So if you have cloud services that are outside of your infrastructure, like Salesforce, Amazon, Office 365, you can set those up here. We can click in and find out what happened 30 minutes ago for a connection to Salesforce, and the route tree is going to show you the current path. The middle row shows the current path taken out to that service. Okay, that's fine, but what happened up here to this connection? Well, this is the route path 32 minutes ago, and this route path has an atrocious amount of latency between these two routers. Well, this is the router that made the choice to take that path, and based upon the domain name, we can see this is part of Salesforce's data center. Therefore, Salesforce caused this problem. Now, if the problem was more towards the middle, that would be a backbone carrier that caused it. If it's more towards the left side, that would be your own ISP that caused the issue. And the last thing I'm going to cover is our ability to predict things. Now, most organizations, they say, gee, I want to get out of this firefighting. I want to move to being able to solve those problems faster. And then I want to move to proactive troubleshooting. I think I painted the picture to you guys that we're the way to do that proactive troubleshooting because we're going to find all the problems that your network has because your network devices already know this stuff. If you could just go solve the problem, it means you're solving it before the user is affected. We figured if we could move you to the next level and start doing predictive technology, then predictive troubleshooting, then you're even further ahead of the game. So because we have so much more data, we can do some interesting analysis. So the first predictor is a cabling predictor. What we're doing with this is we're looking for symbol errors. A symbol error means your Ethernet chipset had to do single bit error correction to fix a physical layer issue in order to pass a valid frame onto layer 2. So we look at this and say, hey, this interface has 17,000 symbol errors? Okay, there's definitely a cabling issue going on. The good news is we haven't dropped any actual packets. But you send someone out to look to see, hey, what's plugged into Chardonnay interface 23? They get the help desk person out there and say, yeah, there's an old Cat3 patch cord out here. Should I replace that? Yes, that's 20 years old. It should have been replaced 20 years ago. And by the way, if you ever take a cable out of service, cut the ends off. I had somebody say, oh, there's a perfectly good cable in this trash can. Let me save this and I'll start using it in the network. Cut the ends off. Prevent anyone from using that again. The bandwidth predictor looks at every interface in the infrastructure, finds out which ones are the most heavily utilized, and which ones are trending towards 100% utilization the quickest. Then we give you the list along with the prediction date. If the worst interface in your network says, hey, a month from now is when it's going to hit 100% utilization, you have some lead time to get some more bandwidth before a choke point is created in your network. So that's pretty much it. At this point, I'll open it up to questions.
So I have a question about, so TotalView, you mentioned modules earlier. I just want to know, like, when I think of module, I think of platform and then modules that fit on top of it, and you have to purchase the platform. Like, how is this productized, I guess is my basic question.
Okay, so the core product is everything I just shown you. So all of that is included in that core. So you deploy—
That's TotalView.
That's TotalView. So you deploy that, it's going to get you all of that information really by the end of the first day of deployment. And that's really the trick, is be able to start solving problems so that people say, gee, I know where I have a VLAN tagging fault. I know that I have microburst link floods over here on this trunk port. And so you know about the problems so you can start fixing them. The modules beyond that allow you to say, gee, let's get deeper into telecom because I have a PBX that is either on-prem or in the cloud, but I need to manage this phone system because I'm a bank. You know, banks have phones. Hospitals, they have phones. If you're a technology company that says, hey, we're just using Teams or we're using Zoom, and you don't have physical phones, you probably don't need our telecom solution. So it's really for any time you have phones. If you're also responsible for security and say, hey, I want my security team and my NetOps team to work together, to have a SOAR solution, to have an understanding of what's going on with vulnerabilities, to have an understanding of what's going on with the IoT devices and who they talk to. Then having that merging of a SecOps and NetOps is really kind of an advanced play for many organizations because sadly, a lot of NetOps and SecOps teams, it's like they don't talk to each other. They might talk to each other saying, hey, you got a problem, can you help us solve this? But it's a rare thing to have them actually collaborate. And by having that same tool say, we're going to solve problems for security, we'll solve problems for NetOps, that collaboration means you're going to save a ton of money because it's one platform versus buying two platforms. There's also no problems with configuration because you're configuring it once and it's going to give you that data. So that's SecOps. And so that's a separate module. And then the third module is the remote user troubleshooting module.
And those are all separate products?
Correct,
Got it.
correct. But you have to have the core to be able to get those modules added on.
So they're real modules, not separate. Got it. Makes sense.